Now see, this is a rod A which is free to fall vertically downward, and this triangular wedge B which is free to move horizontal. As this rod falls, this B moves horizontally, or when this B moves horizontally, this rod A falls vertically downward. Now we have to find the speed of A. What is VA? If this angle is theta and if this B is moving with speed V0. Now so watch the motion of these two rod and this triangular wedge. This rod is moving vertically downward and this triangular wedge is moving horizontally. If we trace the graph, if we trace the motion of these two, the motion of this rod and the motion of the wedge is related by the contact between them. The vertical displacement and horizontal displacement of this rod and this wedge are related. So this is also the example of a constant motion. Now if we see the motion of these two, this distance, suppose this distance moved by A is x. Let this distance is x. For B it is x and for A it is y. So we can say, if we see the triangle, this is y, this is x and this is theta. Now we can say this theta, this theta and this theta are same. This also forms a triangle and these two theta are same. So from here I can say y is equal to, can be written as x tan theta. Now theta is constant, so if I differentiate it, I can say dy by dt, that is equal to dx by dt into tan theta. So dy by dt is the speed of A, so this is VA, it is going downward. This is equal to dx by dx by dt is the speed of this B, which is V0, and this is tan theta. So VA is equal to V0 into tan theta. This is the constant of this thing. This is VA, this is V0, and VA is equal to V0 tan theta. If the acceleration of B is A0, then the acceleration of A is also related as acceleration of A is equal to A0 tan theta, because theta here is always constant. So this is the constant relation between A and B. Now these are the two identical rods joined at O, and if this rod A, this first rod, is free to move horizontally, this is O, it is hinged at O. If this rod is moving horizontally with a speed V0, this is V0, then this point P will move horizontally, let this be Vx, and this point P will also move vertically downward, let this be Vy. Now for this movement, see the motion of these two rods. Now see the motion of these two rods. This is the point P, which is the junction of these two rods. If this end is moving with a speed V, then watch the motion of this point P. Watch the motion of this rod, this point P. As this rod is moving, this end is moving, this P point is moving horizontally as well as it is going vertically downward. So we will analyze the motion of this point, these two rods. This is the trace of this point P. This point P is going horizontally as well as it is going vertically. Now we can solve it like this. Let the separation between this O and P, this is x. Now we can say this is capital X. So we can say x is equal to, this length is, if this angle is theta, I think this is also theta because this is isosceles triangle, and now we can say this distance, this length is L cos theta, this is also L cos theta. So I can say this total x is actually 2L cos theta. This is the separation between this O and P. Now if I differentiate this, we get dx by dt, that is equal to 2L cos, differentiation of cos theta is minus sine theta into d theta by dt. So from here dx by dt, as we know dx by dt is actually v naught. So I will write here v naught, which is equal to minus 2l sine theta into d theta by dt. So from here we get d theta by dt is equal to minus v naught by 2l sine theta. This is our first relation. Now for this point P, I can say the x coordinate of point P is L cos theta. X coordinate of this point P, if this is our origin, the x coordinate of this point P is xp is, this distance is L cos theta. And in the same way y of point P is, this is yp, which is equal to, this is y coordinate of point P, which is equal to L sine theta. So if I differentiate this, dxp by dt is the speed of point P along x-axis, this is vx, which is equal to minus L sine theta d theta by dt. Now if I substitute the value of d theta by dt from our first expression, I will get this as minus L sine theta into d theta by dt means minus v naught by 2L sine theta, and this is equal to v naught by 2. So vx is equal to v naught by 2, means point P is moving along horizontal direction with a speed given by v naught by 2. Now for y coordinate, now we know y coordinate is of this point P is L sine theta. As I have written here, this y coordinate, this length is L sine theta, because this is L, so this is L sine theta. Now as we know yp, that is equal to L sine theta. If I differentiate this yp, I get dyp by dt, that is equal to L cos theta into d theta by dt. If I substitute the value of d theta by dt here, then I get dyp by dt, that is equal to L cos theta into d theta by dt is minus v naught by 2L sine theta. From here I can write d theta by dt is minus v naught by 2L sine theta. So from here we can say this LL will cancel out. We get this as minus v naught by 2 into cot theta. So from here we can say v of this point P along y axis is minus v naught by 2 into cot theta. Since this yp is going downward, so this dyp by dt is negative. So this is your vy and this is your vx of this point P. So we can say the speed of point P is root over vx square plus vy square, and vx square plus vy square comes out to be root over vx means v naught by 2 whole square, and vy is, it is v naught by 2 into cot theta whole square. So this comes out to be v naught by 2 into root over 1 plus cot square theta, and we know 1 plus cot square theta is cosec square theta, and root of cosec square theta is cosec theta. So this is the speed of point P, and this is the final answer. This is another question. Find the relation between acceleration of block A and block B. This block B is moving horizontally with acceleration A, then what is the acceleration of block A? We will watch a video clip. See, this is block A, this is block B. As this block B is moving, this block A is moving horizontally as well as moving vertically downward. This block B is moving horizontally, this block A is moving horizontally as well as vertically. Now if we trace the path, now this is the motion of block A. With respect to ground, block A is going like this. It is moving horizontally as well as vertically. So after seeing this video, it is quite easy. As we have seen, this block A is moving along this line. So block A is having horizontal acceleration A, because this block These two A and B are in contact. So when this block E moves horizontally, we get a string from here, and this is the reason for movement of this block A downward. So block A is moving horizontally with acceleration A. It is also going downward with acceleration A. So horizontal acceleration of block A is A, and vertical acceleration of block B is also A. So the acceleration of block A is a root over ax square plus ay square, which is equal to root 2a. So this is the acceleration of block A with respect to. Now suppose this is block A, the block B, now here the string passes like this. Now we have to discuss the constant, the acceleration of block A, if the acceleration of block B is small a. Now we will watch a video. Now see the motion of this block A and block B. See, this block B is moving horizontally. This block A is moving horizontally as well as it is going downward. It is moving forward, it is moving horizontally, and it is also going vertically downward. Now this is the trace of motion of body A. This block B is moving horizontally. This block A with respect to ground, it moves like this. In horizontal direction it is same, but in vertical direction it is double. Now see, when this block A, as we have seen, this block B A has moved like this. Now the distance moved by this block A and B, the horizontal displacement is A, but in vertical direction it has moved some more distance, because when this block B moves, we get a string from here. When this block B moves forward, the string which we get from here is this one. This string become free, and here we also get some string. So this is x, this is also x. So in vertical direction it is 2x. So we can say the acceleration of block A along x axis is a. The horizontal acceleration this block A is ax, which is a. But in vertical direction, ay, in vertical direction this block A moves twice the distance as moved by this block B. So it is 2a, because this block A is moves double distance. So the acceleration of block A is root over ax square plus ay square. Now this is also equal to root over 2a square plus a square, which is equal to root 5a, and this is the answer. This is the acceleration of block A, and block A with respect to observer on ground, it is moving like this. This question can again be solved by another method like this. Suppose an observer is sitting here. This is the observer who is sitting on ground. He measured this distance as x1. Let this distance be x2, and let this distance be xa. So the total length of the string as measured by this observer is x1 plus x2 plus this x1 plus xa. This is the total length of the string. This is x1, this is x2, this is x1, and this is xa. Now if I differentiate it, dl by dt, that is equal to 2 times dx1 by dt plus dx2 by dt plus dxa by dt. Now from here we know the total length of the string is always constant. So dl by dt is 0. So this is equal to 2 times. What is dx1 by dt? Is the speed of B. Since block B, let it be Vb. Since x1 is decreasing if block B is moving in this direction with speed Vb, so it is minus Vb plus dx2 by dt. dx2 by dt is 0 because x2 will remain constant, plus dxa by dt is Va, because xa is increasing. If this block A is going downward, xa is increasing. Now we can say Va is equal to 2 times Vb. So from here we can say acceleration of A is 2 times acceleration of B, that is AA. So this is your VA, and in vertical direction, so we can say the vertical acceleration of block A is 2A, and horizontal acceleration of block A is only A. So horizontally this block A is moving acceleration A, and in vertical direction its acceleration is 2A. So the acceleration of block A is root over ax square plus ay square. So this is equal to root 5 times A. This is the constraint. This is the relation between acceleration of A and acceleration of B. Now suppose this is a horizontal rod which is fitted between the two vertical walls. This is a ring which is free to move horizontal direction. This is a block A. If this block A is moving vertically downward, then we have to calculate the speed of this ring. Now block A is going downward with a speed V0. Now we will analyze this motion. Now watch the motion of this ring and this block B. If this block is going downward, this ring is moving horizontally like this. If we trace the path, now we will relate the motion of this ring and this block. Let this angle, let at any instant, let this angle be theta. Let this be distance A. Since this A will remain constant, let this distance be x. Let this be y. So I can say the total length of the string L is this length plus this length. So it is equal to y plus root over a square plus x square. This is the total length of the string present here. This distance is y, this is y, and this length is root over a square plus x square, because this is always right angle triangle. So this is the total length of the string. If I differentiate it, dl by dt is equal to dy by dt plus 1 by 2 root a square plus x square into 2x dx by dt. So this 2 will cancel out. We know the length of the string is constant, so dl by dt is 0, and dy by dt, since y is increasing, so dy by dt is plus v0 plus x by root over a square plus x square into dx by dt. Now since x is decreasing, so this can be written as minus Vr. Now we also know cos theta is equal to x divided by root over x square plus a square. So from this figure I can say V0 is equal to Vr, and x by root over a square plus x square is cos theta, it is cos theta, or Vr is equal to V0 by cos theta. So this is equal to V0 sec theta. This is the answer. This question can also be solved like this. Suppose after some time this ring move a distance Vr and the strings becomes like this. This moves a distance V0. So I can drop this angle is theta. So this length is Vr cos theta. So this Vr cos theta is the length of the string which we get by the movement of this ring. So this Vr cos theta is equal to V0. So this is equal to V0. So from here this is our answer. So from here we can say Vr is equal to V0 sec theta. This is the answer. Now this is again a new question. This is a block A which is by a pulley, and this is a string which passes through another pulley, and the one end of this string is pulled with speed V0. Now we have to calculate what is the relation between V0 and VA if this angle is theta. Now let this length be y. Let this distance be a. So this length is root over a square plus y square. This is also root over a square plus y square, and let this length be y naught. So the total length of the string can be written as root over a square plus y square into 2, because this length and this length, plus y naught. This is the total length of this string. Now if I differentiate it, I get dl by dt, that is equal to 2 times root over 2 a square plus y square into 2y dy by dt plus dy naught by dt. Now from here dy by dt is VA. So it is 2 will cancel out. We get 2 times y by root over a square plus y square into dy by dt. Dy by dt is VA. It is minus VA because y is decreasing. If this block A moves upward, y decreases. So dy by dt is minus VA plus dy naught by dt. Dy naught by dt is V naught, and this is equal to 0. So from here we can say this is 2, and we get y by root over a square plus y square is cos theta. So it is 2 cos theta minus VA plus V naught is equal to 0. So or V naught is equal to 2 VA cos theta, or VA is equal to V naught by 2 cos theta. This is our answer. A block A accelerates to the left at 6 meter per second square from rest. Find the velocity of B after 3 seconds. Also find the distance traveled by the B in this time. Now the question says this block A is moving towards left with acceleration of 6 meter. This is the acceleration of A, which is equal to 6 meter per second square. So as the acceleration of A is 6 meter square, so this is the acceleration of B. So first we have to find the relation between acceleration of A and acceleration of B. If this block A is moving horizontally in this direction, it needs a string. We need a string here. So if this is XA, and if this block B moves a distance XB, we get a string from here, this and this. This must be equal to 3XB. So from here we can say acceleration of A must be equal to 3 times acceleration of B. So acceleration of A is 6. This is equal to 3 times acceleration of B, or acceleration of block B is 2 meter per second square in upward direction. Now find the velocity of block B. So we can say velocity of block B is u plus A of B into t. So it is equal to 2 into time is 3. So this is 6 meter per second. So the first part of the answer is 6 meter per second. And we have to calculate the distance. So distance traveled by B is u of B into t plus 1 by 2 acceleration of B into t square. So distance traveled by B is equal to u of B is 0 plus 1 by 2 acceleration of B is 2 and the time is 3. So it is equal to 9 meter. This is the distance traveled by B. Block A moves down at a speed of 3 meter per second. In this situation, this block A is going downward with a speed of 3 meter per second. Find the velocity of other two blocks, this block B and block C. Also find the velocity of point P with respect to C. Now first, let the observer is sitting on this blue line. The observer is sitting here, and this block A is going downward with a speed of VA, that is equal to 3 meter per second. Now if this observer measure the length while sitting at O, so he will measure this length as XA, this as XB, and this as XC. So this is the length measured by the observer. This is XA, this is XB, and this is XC. Now there are two strings. So length of first string L1, this is first string. The total length of first string is XA, this side, plus this length is also XA, plus XA, plus this length XB, plus XB, plus this is also XB, so it is XB, plus this side is also XB. This is the total length of first string. This length starts from here. This is XB, 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 and this is XA and XA. In the same way, the length of second string L2. This is our second string. The length of the second string is 2 times XC plus XB. This length is XB. So if I differentiate this length 1 dl1 by dt, that is equal to 2 times dxa by dt plus 3 times dxb by dt, and we know the length of first string will remain constant, so this is 0. So that is equal to 2 times dxa by dt. Since a block is going downward, so dxa by dt is plus 3, so it is plus 3, plus 3 times dxb by dt. So dxb by dt is not known. This is equal to 0. So from here we get dxb by dt is equal to minus 2. Means this block B is moving with a speed of 2 meter per second in upward direction, such that this B is decreasing. This is the speed of block B. In the same way, if I differentiate the length of the second string, this second expression, we get dl2 by dt, that is equal to 2 times dxc by dt plus dxb by dt, and that is also 0. This is also 0. So from here we get 2 times dxc by dt. So dxc by dt is not known, minus dxb by dt is minus 2, so that is equal to 0. So from here we get dxc by dt, that is equal to 1. So this block C is going downward with a speed of 1 meter per second. Now as we know, this block A is going downward with speed VA. This block B is going upward with speed VB, that is 2 meter per second. And this block C is going downward with 1 meter per second. This is VC. Now we have to calculate the speed of P with respect to C. Now this block A is going downward with a speed of VA, that is 3 meter per second. This block B is going upward with a speed of 2 meter per second, and this block C is going downward with 1 meter per second. Now if we see this point P, the length of the string from here, this distance is 2, this length is also 2, this length is also 2. So this point P moves a distance of 2 plus 2 plus 2, that is 6 meter. So speed of point P 6 meter per second in upward direction, because this string and this string will move this point P 6 meter upward. Now this C is going downward with speed 1. So speed of P with respect to C is 6 plus 1, that is equal to 7 meter per second. So this is the speed of P with respect to C. Now as we know, Yp, that is equal to L sine theta. If I differentiate this Yp, I get dyp by dt, that is equal to L cos theta into d theta by dt. If I substitute the value of d theta by dt here, then I get dyp by dt, that is equal to L cos theta into d theta by dt is minus V naught by 2L sin theta. So from here we can say this LL will cancel out. We get this as minus V naught by 2 into cot theta. So from here we can say V of this point P along y axis is minus V naught by 2 into cot theta. Since this yp is going downward, so this dyp by dt is negative. So this is your Vy and this is your Vx of this point P. So we can say the speed of point P is root over Vx square plus Vy square, and Vx square plus Vy square comes out to be root over Vx means V naught by 2 whole square, and Vy is V naught by 2 into cot theta whole square. So this comes out to be V naught by 2 into root over 1 plus cot square theta, and we know 1 plus cot square theta is cosec square theta, and root of cosec square theta is cosec theta. So this is the speed of point P, and this is the final answer.